Hello, this video is about biogeography, one of my favorite parts of geography. It's looking at where do things live, mostly plants and animals rather than people, and why do they live there is the simple way of putting it. That why do they live there is made up of both environmental and historical factors of why things live in specific places. Environmental factors are mostly going to be based on like local ecosystem processes, which is what this video is mostly about. Um, and then the historical factors is what kinds of things have happened in a place in the past. Uh, so, was there a volcanic eruption? Have people been there or not? Were there glaciers? What are the rivers? Is it a desert? What climate did a place have before it had the one it has now? So, biogeography, super interesting element of geography. Biologists study it, geographers study it too. A lot of mapping work and field data collection that can be done in biogeography, which is part of why I like it. Now, within biogeography, you've been introduced to it online. Um, Geographers often will focus on ecosystems or a type of ecosystem, or range. Now, ecosystems are kind of categorized within biomes. So there's a bunch of different types of biomes that mostly relate to climate types that we talked about: desert, forest, Mediterranean, savanna, grassland, tundra, boreal forest, things like that. Now, within each biome, there are hundreds of different types of ecosystems. Ecosystems are local, they're small. You could have an ecosystem that fits inside a jar. Like people will post on the internet of like, oh, I left this jar locked outside for 10 years and it's full of plants and microorganisms and all kinds of stuff. It's a self-contained ecosystem that happens. So ecosystems can be small. They can also be very large and cover hundreds of miles or a few miles. So they absolutely vary in range in real life. If it's not in a bottle, they could be a 10-foot spot can be a almost ecosystem that's really an ecological system. So it's a bunch of interconnected processes that have some set of local conditions that make them unique. That's an ecosystem. It's based on the local conditions. And an ecosystem is made up of abiotic and biotic components. Now, abiotic means non-living, without life. Abiotic. Biotic is the living part of an ecosystem. So just biology, study of living things, biotic, living stuff. Abiotic, not living stuff. Now, what are the abiotic parts of an ecosystem? Usually in class, I'd have people shout these out and we'd talk about them that way. This is fine though. So air. Every ecosystem on Earth is going to have air. Air differs in some small ways based on mainly like proximity to human activity. So if there's an ecosystem right next to a freeway, or housing development, coal-fired power plant factory, any human stuff, then that ecosystem is going to have worse air quality than other ecosystems. And that is a measurable thing. You could go out with an air quality monitor. We have some in the department. I could send you out right now if this wasn't online. And you could measure the air quality next to a freeway and then in grades moving away from that freeway, and you'd have a noticeable increase in air quality the further away that you move from human activity. So air has a big effect. The other main way that air is going to differ between ecosystems is in air pressure. Low altitude places have higher pressure generally, and as you gain altitude, there is gradually lower pressure. So that when you go to the top of a mountain, there's less oxygen. That's going to have a small effect on plant life living there. Plants need carbon dioxide, and if air is less dense at the top of a mountain, there's less carbon dioxide. Plants are usually fine, and like you can have forests growing at 10,000 feet sometimes in warmer environments. But like LA County, as you go up in elevation, there is lower air pressure, and you do have some differences there. Now, next abiotic component after air, water. Spent a whole bunch of time talking about water in this class. We have a whole chapter on atmospheric moisture, precipitation, and water differences. We also talked about how water changes based on air pressure, which is really kind of based on like your latitude and proximity to the ocean. So every place on Earth has different amounts of water that they receive. They get different amounts of humidity, different levels of humidity, different rainfall levels during the year. You get snow or not. And the amount of water can change in an area over, as you saw it, hopefully in chapter 9 with exposure, over the course of like two sides of a hill. One side that's facing the sun is going to be usually the south face in the northern hemisphere, the windward side in some cases, is going to be drier, hotter, and get less water. And then the other side of the slope, usually the north face in the northern hemisphere, is going to get more sun protection. It's dark on this side, and it's overall wetter. So you can have two totally different ecosystems on either side of a hill based on that exposure. That'll also happen in valleys. So here's a south-facing valley, here's a north-facing valley. This valley side is going to be drier, this side's wetter based on sun exposure. So valley or mountain, same thing. Water varies in small locations, and it varies over broad expanses. When there's small local variations in any of these things, you can call that a microclimate. So like if there's a big rock and that rock covers an area in shade all the time, and that rock stays slightly cooler in the summer or slightly warmer in the winter or whatever, you'll have a microclimate around that rock. Or if the rock blocks wind from blowing around, you can have a microclimate and a microecosystem just under like a big boulder that varies from the rest of the landscape. Third abiotic component of an ecosystem, dirt or soil. I'm okay with dirt. Now, a lot of people hear the word dirt and think, oh, that's dirty. I don't like it. Clean it off. Outside is dirty. Outside stuff isn't really dirty. Human stuff is the dirty stuff. Soil is maybe a better word for it, but soil technically has biotic components into it. Like the definition of soil is that it's dirt plus water, air, and microorganisms. And then the last abiotic component is sunlight. Sunlight, which gives us temperature or thermal energy. As we've talked about in several chapters, chapter 5 and 9 mostly, you know that temperature differs around the world depending on location. Based on latitude, temperature changes, amount of sunlight exposure changes. Based on altitude, temperature changes. We just talked about that in chapter 5 and 7 and 9. So temperature differs vastly wherever you go. So based on these 4 abiotic non-living parts of an ecosystem, the biotic part, that's the part that most people think of when you think of an ecosystem. This part exists because of the abiotic components that allow the life to exist. So whatever life you find in an ecosystem exists because it has the right air quality, the right amount of water, not too much water, because if there's too much water than it, or more water than an ecosystem got, then it allowed different plants to come in and invade. Soil type, certain plants and animals prefer or require certain soil types. And then temperature. Palms, for example, will die if it freezes. So there's a little thing at the top that if that freezes on a palm tree, then the palm tree dies. So like palms are limited based on temperature. Anywhere that it freezes, normally, you're not going to find any palm trees. And there are many, many plants that have similar temperature ranges that they can survive in just that one range. Now, animals tend to be more adaptable. They can get up and walk away most of the time. So animals kind of are less strict on their abiotic requirements, and say a coyote is a really good generalist. You find those all over North America, and if they don't like the conditions in a spot, they just get up and walk away. Coyotes are also cool because they can live in like suburbs and cities and neighborhoods, and they figure out the abiotic components there. But biotic part of an ecosystem exists because the abiotic components let it happen. Now, if you look below this video, there's a photo of a place in Death Valley called Fish Creek. Fish Creek, Death Valley is a pretty unique ecosystem. It's this kind of tiny thing that you see in the photo below. There's some water flowing through it. It's a river, but it's actually a saltwater river. And so the water that ends up in Fish Creek gets there because there's some rain that happens in the mountains 100 miles away on the edge of Death Valley. And then in the summer, or in winter, that falls as snow. As it warms up in the spring and summer, that snow melts and it trickles down 100 miles away, and it ends up, weaving through the landscape, goes under some roads, does a bunch of different things, picks up salt from the ground along the way, and then pools in this depression that is Fish Creek. So the water is salty by the time it gets there. And then the plants that are in that photo exist because of the amount of water that's there. The water is only there for part of the year. It trickles down in the springtime and then dries up by the end of summer, maybe early fall, depending on how much snow there was, how much water you got during that wet part of the year. And then it dries up. So the fall and winter are totally dry until spring when the water comes back. So the plants sit there and wait for the water to come back, and then when it's the rest of the year, the area is just totally dry. So plants exist because this water trickles down. Soil salty. Most plants don't want salt. Like in ancient times, if you wanted to destroy a civilization, like you went to war with them, okay, we beat them, but we really hate you, you'd go and salt their fields, and so you can't grow anything once the fields are salted. Well, the plants that grow in Fish Creek can handle that salt. They like it, they can tolerate it, and you see from the photo, there's no other plants growing in that spot because of the salt. So the ones that are successful are salt tolerant. Temperatures, it's hot in Death Valley. It does get cold in the winter, but it's easily 120 degrees in the summertime. Air quality is good, but dusty. Water, it's dry, it's a desert, but you get that trickle down from the mountains. So that's the abiotic part of Fish Creek. Now, the biotic part that lives there, you have the plants that use the water, you have microorganisms that live in the water, eat the dead plants. The plants use those microorganisms as nutrients. There's actually fish in the water in Fish Creek. They're called desert pupfish. They're like this big, they're quarter size. And those desert pupfish are actually like fossil fish. They're relics of the water that used to be there. So at the end of the last ice age, 13,000 years ago, water from melted glaciers formed these sizable lakes in the western United States. As the glaciers completely melted across the western United States, the lakes dried up, and so the fish that were in those big lakes slowly went extinct or died off or locally extinct from all those lakes. And so where Fish Creek was this big lake full of fish and normal lake stuff, and then as it dried up, it got smaller, smaller, smaller. The fish die off and die off and die off. And the water gets saltier and saltier and more concentrated as the fresh water evaporates, and it's left with just salt water in this one small part. And so at the end, now, the only fish that live in that area, desert pupfish, are able to, because they can burrow underground, they wait for the water to, they burrow underground as the water is drying up. They hibernate underground where it's dry for part of the year. And then when the snow trickles down from the mountains 100 miles away, they come out of burrow, reproduce, lay their eggs, all that stuff, and then die. And then the next generation does it again. And so they exist only because of that water that trickles down from the mountains 100 miles away. And then because they're able to hibernate and wait for the water to come back at other times of the year. So kind of unique thing, you have a hibernating fish that can live for part of the year without water. So they're protected, they're endangered, don't go step on them when they're underground. That's an actual federal offense, don't do it. So if you change any one of these abiotic components in Fish Creek, for example, then the entire ecosystem collapses. If you have a freeway that goes by and maybe the microorganisms die off because they're sensitive to that, then the plants don't get nutrients and the fish don't have food and it collapses. If you build a new highway that cuts off the water to Fish Creek, then the whole thing collapses. If climate change makes it warmer so that you get rain that falls in the mountains instead of snow, then that rain trickles immediately down. It changes the growing season. It changes the fish hibernate burrow cycle. They probably die. If the soil is less salty, say, then other plants move in, and maybe the ecosystem would be fine if you had more plants, maybe not. Maybe trees come in and they use up all the water, so then the fish have nothing to eat. If it gets hotter, then that snow evaporates sooner. Maybe it doesn't make it all the way down to Fish Creek, so the fish lose their water. So any one of these things could be changed to completely destroy that one ecosystem of Fish Creek. And that's just one example of an ecosystem that I can just guessed at most of those things from the ecosystem as it appears. You could take any ecosystem anywhere in the world and it is just as fragile, it's just as breakable. And people need to realize that we don't know a whole bunch more about ecosystems than we do know about ecosystems. Or if you change any one thing, then the ecosystem as a balanced system falls out of balance and collapses. Okay, have fun.